Hello viewers, I trust you are good today. Right? Before us is the basic trigonometric ratios, their reciprocals, and few other things that we'll be looking at. So this is the introductory aspect of the beautiful concept of trigonometry. So we'll just be saying few things, little things that start the big concept of trigonometry. To start, we are looking at the right angle triangles and how to label the sides of the right angle triangles. So if I call this triangle A, the hypotenuse is always the longest side, or the side that is facing the angle 90 degree. So if this is angle 90 degree, the line that is facing the angle 90 degree is the hypotenuse. So if our angle is here, angle theta, then this place will be called the opposite. But if the position of the angle is switched from here to this place, as we have it in the second triangle, say triangle B, then this side facing the angle will be the opposite. Again, if the angle is here, the line facing the angle is the opposite. Then if the angle is here, then the line facing the angle is the opposite. Okay, since we have identified the hypotenuse and the opposite, then the third side we are left with will now be called what? The adjacent. So this is the adjacent in this case, and this is the adjacent in this case. So that is how to label our right angle triangles. Okay, moving on is the trigonometric ratios, the basic trigonometric ratios themselves. And they are shortened with these three words. So, ka, tua. So is sine, and that is sine of the angle theta that we have here, or the sine of the angle theta here. And sine of angle theta is the ratio of the opposite over the hypotenuse. That is why we have O here for opposite and H is hypotenuse. So ratio of the opposite to the hypotenuse, that is sine theta. Then the next one is C, which is ka, and that is cos theta, cosine of theta. Cosine of theta is the ratio of the adjacent to the hypotenuse. Okay. Lastly, or thirdly, is TOA, and TOA is tangent, tan theta, tangent theta, shortened for tan theta. And that is the ratio of the opposite to the adjacent. So these are the basic trigonometric ratios. It is the ratio of one side of the right angle triangle to the other. The next concept is the concept of the reciprocals. And what do we mean by reciprocals? For example, if you are given A over B as a fraction, what is the reciprocal of A over B? The reciprocal of A over B will be B over A. That is the concept of reciprocal. Okay, now this is sine theta, and this sine theta is assumed to be a whole number or a whole concept. And by the idea of a whole concept, it always has a denominator of 1. So what is going to be the reciprocal of sine theta? Of course, it's going to be 1 over sine theta. And 1 over sine theta is called cosecant theta. Cosecant theta. And it is usually shortened as cosec theta. The full name or full pronunciation is cosecant theta, but it is shortened as cosec theta. The next is the reciprocal of cos theta. The reciprocal of cos theta is 1 over cos theta. And 1 over cos theta is called secant theta. And secant theta is shortened as sec theta. Thirdly is the reciprocal of tan theta. And reciprocal of tan theta is 1 over tan theta. And this is technically called cotangent theta. cotangent theta, and cotangent theta is shortened as cot theta. Cotangent theta is shortened as cot theta. So that's the concept of reciprocals. Alright, few other facts you can have under basic trigonometric ratios or trigonometry generally is or are: number one, tan theta equals sine theta over cos theta. It means that when you divide the value of sine theta by cos theta, it's actually going to give you the value of what? Tan theta. That, of course, can be proven. Just pick sine theta to be opposite over hypotenuse. In the place of sine theta, put opposite over hypotenuse. And in the place of cos theta, put adjacent over hypotenuse. Put it there. This division line, you can use the real division sign for it. Do your switch. Division changes to multiplication, then the right hand side will be switched over. You take the reciprocal of the right hand side. By the time you cancel out the ones that are similar, you see that you are going to arrive at opposite over adjacent, which is the equivalent of tan theta. So that is how to prove that. So that is one fact. Another fact we can take note of is that sine theta and cos theta are complements. They are complements of each other. They are complements of each other. What do I mean by that? If you have any two angles, if you have angle A plus angle B, if you add angle A and angle B and you see they are 90 degrees, it means that angle A is the complement of angle B, or angle B is the complement of what? Angle A. Because by the definition of complementary angles, any two angles such that when you add them together, they give you 90 degrees. Those two angles are called complementary angles. So angle A and angle B are complementary angles when they add up to 90 degrees. Now, what is the implication of this to sine theta and cosine theta when we say they are complements of each other? It is saying that if you pick angle A and you do the sine of angle A, the answer you are going to get will be equal to the cosine of angle B. Why? Because sine and cosine themselves, they are complements of each other. No wonder if you do sine 30 degrees, it will be equal to what? 1 over 2, or in some cases 0.5. Of course, they are the same. Now, what is the complement of angle 30 degrees? What must you add to 30 degrees to give you 90 degrees? Of course, it's going to be what? 60 degrees. So, by the idea that we have here, it is saying that if we look for the value of cos 60 degrees, it's also going to give us 1 over 2, which is the same thing as 0.5. Don't doubt it. It is the same for every angle as long as those two angles are complements of each other. Now, you can pick any other two angles that are complementary angles. Say, for example, 1 and 89. 1 degrees and 89 degrees, they are complementary angles, because if you add 1 to 89, it's going to give you 90 degrees. Say 41 degrees and 49 degrees. 41 degrees and 49 degrees, they are complementary angles. So if you look for the sine of 41 degrees, it's going to be the same thing as the cosine of what? 49 degrees. So you can try that on your own. Sine 41 degrees will be equal to cosine 49 degrees. Why? because 41 and 49 are complementary angles, and sine complements cosine just as cosine complements sine. Also, based on the same fact, if you pick cos 41 degrees, instead of picking sine 41 degrees, you choose cos 41 degrees, still going to be the same thing as sine 49 degrees. These are things you can quickly fact check using your calculators. Pick up your phone, pick up your calculators. Find the value of sine 41 degrees, note it down somewhere, then find the value of cos 49 degrees. Pick it up and you are going to see that they are the same. Find the value of cos 41 degrees, find the value of sine 49 degrees, compare them, you see they are going to be the same. Pick any other two complementary angles again and keep trying as many values as you can try. You'll see that their values will always be the same. So that is another fact to say that sine theta and cos theta are complements of each other. Third fact, tangent tan theta and cot theta, that's cotangent theta, are complements of each other. That is, tan theta and cot theta also complement each other, just like sin theta and cos theta complement each other. So again, if angle M plus angle N equals to what? 90 degrees, it means that M and N are complementary angles. So if you look for tan M, tan of angle M, it will be the same thing as cotangent of angle N. That is another fact. Okay, so let's look at something. Sin theta is written in full as sine, shortened as sin. Cos theta is written in full as cosine, as cosine. Now, when I write my cosine and I want to explain that concept, I like to write my O in capital letter. There is a reason for that. So that I can tell you that this is sine and this is complement of sine. The word complement. I coined that myself. You may not see it in any textbook. So that is sine and then complement of sine, which is now called cosine. Then we have tangent. Tangent, this is cosine, and cotangent. Also, we can safely say that this co means complement of tangent theta, or whatever angle that we are given. Okay, so those are facts that you can take note of. Sine and cosine complement each other. Tangent and cotangent also complement each other. Okay, so the last thing we'll be looking at today, based on this particular concept, is that in trigonometry, when you see sine squared theta, what does it actually mean? It means that when you have gotten the value of sine theta, you are going to square that value. So instead of writing it like this, you will most likely see it like this in trigonometry. That is how it is represented in trigonometry and mathematics. Also, when you see cos squared theta, it is same as cos theta being squared, and the same thing is applicable to the last one, which is tan squared theta. Tan squared theta means tan theta, after getting the value of tan theta, then you square it. Okay, so let me give you one last snack before you move or we move. We end it for today in the video. It is that when you have sine squared theta, you get the sine of the value of an angle, and for the same angle, you get the cosine. And you square the sine, and you square the value of the cosine. You square the value of the sine, you square the value of the cosine. When you add them together, they will always be equal to what? 1. Again, you can fact check that using your calculator. Assign any value to sine to theta. If you like 30 degrees, if you like 21 degrees, if you like 84 degrees. But take note, whatever value you assign to this theta, that is the same thing that this theta is going to be. So if this is sine squared 84, this also has to be cos square what? 84. That is, find the value of sine 84, square it, keep it aside. Find the value of cos 84, square it, also keep that aside. Then add the two values together. It will always be equal to 1. Like I said, you can fact check that using your calculator at home. Okay, we won't go more than this for this introductory aspect of our trigonometric ratio and a few other things, including the reciprocal. So from here, by the time I want to make the next video, I'm going to pick it up from this particular spot, and then we can see other things that can come under basic trigonometric ratios, the reciprocals, and by extension, identities. Till that time, till I come your way again, please stay good. Thank you.